The natural world provides a wealth of fiber types. These have been used by cultures in every country throughout history. Strength and durability are balanced by softness and flexibility when fibers are spun into thread and then woven into textiles. Each fiber has its own nature, and each will react differently to mordants and to dyes. The vast range of fiber types makes the dyer's art endlessly fascinating. For the dyer, the fiber world is divided into two types: fibers from animals and fibers from plants. Protein fibers are from animals. These are wools, hairs, and silks. Cellulose fibers are from plants. These are cottons, linens, hemps, nettles, barks, leaves, or plant fiber. Natural dyes work best on natural fibers, so we will not be considering synthetic fibers. Protein fibers are easier to dye than cellulose fibers. That's because they require only a single mordant, and often the dyeing time is shorter. Some cellulose fibers may require more time to scour. Cellulose usually requires a tannin treatment prior to the alum mordant. The additional work involved with cellulose is well rewarded in the results. Yarns and fleece are easier to dye than fabrics. Yarns are usually in 50 to 100 gram skeins, which makes them easier to handle in a pot. Woven materials require care and practice to get even coverage. A suitably large dye pot is very important. Tightness and type of weave is also a consideration. It can be a challenge to get the dye into a tight twill weave, for example. Running fabric and garments require sufficient space in the dye pot. For running fabrics, this can mean specialized equipment, such as a jigger machine. At Maiwa, we can dye 1 to 3 meters of linen or 3 to 5 meters of silk at a time. For this, we use a large stainless steel or copper pot. Garment dyeing involves finishing the garments prior to scouring, mordanting, or dyeing. For this, you must use sewing thread that matches your fiber type, either cellulose or protein. So for linen, we use cotton thread, and for silk or wool, we use silk sewing thread. Don't use synthetic thread, as it will not take the dye. Garment dyeing is something we've tried but have not perfected in all ways, but is something we keep working at. We love the look of garment dyeing. With pre-worn garments, you also need to be careful of areas which have been affected by wear or perspiration, as these areas may dye unevenly. So basically what I'm trying to say here is that if you're starting out, it may be easy to work with wool or silk yarns. With wool or silk, you can get the hang of scouring, mordanting, managing the dye pots, managing the heat, working with raw dye stuff, rinsing, drying, and then feel good about it. After wool and silk, let your world open up as you gain confidence in more complicated dyeing, linen yarns, hemp fabrics, a cotton silk garment, or a wool shawl. Now let's look at various fibers in depth to understand how they take natural color. What are the challenges and what are the secrets? Let's look at wool. Wool usually comes from sheep, but cashmere and mohair come from goats. Mohair comes from the Angora goat, while the remarkably soft Angora fiber comes from the Angora rabbit. Kiviot is a rare fiber which comes from the muskox. Camel hair comes from camels, and we also get fibers from the 4 camelid breeds which are indigenous to South America: Alpaca, Llama, Vicuña, and Guanacos. Many of these wools are not naturally white. They have a shade that can be successfully overdyed with natural dyes. So in addition to white or natural fibers, we love to use yarns and fabrics that are made from naturally colored fibers. When we dye fibers and fabrics that come naturally gray or brown or golden, we obtain a combination of the fiber color and the dye color. Sometimes these combinations are remarkable because of the rare shade you get as dyes interact with fibers. Working with naturally colored fibers also multiplies the color palette that can be obtained from a single dye. There are over 1,000 distinct breeds of sheep in the world. At Maiwa, we love to explore wools from rare breeds or heritage sheep, such as the Santa Cruz Island sheep, blue-faced Leicester, Shropshire, Jacob, Ramie, Faroe Island, to name just a few we have worked with. As artisan dyers, we are sensitive to the fact that if we do not make a concerted effort to work with rare breeds, both wool and silk, then we risk losing them. Breed-specific wool is wool that comes from a single breed rather than a blend and is wonderful to work with because the dyer and the weaver, knitter, crocheter has the opportunity to learn the particular qualities of a single breed and work with those qualities. When applied to wool, the term organic means that the sheep have been raised on organic pastures or with organic feed. As with organic plant fibers, we have found that organic wools take up mordants and dyes with ease and often dye noticeably darker. Wool has a unique cellular structure that makes it easy to mordant and dye. The surface of the hair is made up of a series of overlapping scales that open in water. These scales open further in hot water. For this reason, most recipes for mordanting and dyeing wool recommend hot water. But because wool scales are directional, they will catch on each other more easily when open, and this is what leads to felting. Felting can be avoided by gentle handling and slow, gradual temperature changes. Deshi wool is the local wool of the shepherds in the Kutch Desert of India. It is hand-spun and slightly rough in texture. Deshi is a Hindi word which means country, as in the countryside. Deshi wool is used by a number of communities living in the Kutch Desert, including Rabari pastoralists and Vankar weavers. Shamji Vankar and his extended family work directly with Rabari women to spin the wool. The Vankars are accomplished dyers and weavers who use Deshi wool in both traditional and contemporary pieces. We find that scouring camelid wools in the fleece stage gives more even dyeing. The wool of alpaca and llama have air-filled cells called medulla that can prevent dyes from penetrating the fibers. The result can be pale shades or an uneven salt and pepper effect. Longer scouring, mordanting, and dyeing times of these fibers greatly improves the depth of shade. We leave yarns in our alum mordant for 24 hours after bringing to temperature. We will also leave the fiber in the dye bath for 24 hours. Tip: Superwash wools have been treated with a polymer that covers the scales of the wool to help prevent felting during washing. This coating will also prevent even dyeing. Tip: The nature of wool is such that it is weaker when wet and may be damaged by heat. Always handle wool gently while scouring, mordanting, and dyeing. Tip: Some mordanting and dyeing can be done unheated. We explore this technique in mordanting and dyeing modules. Tip: We recommend color mixing in a single bath rather than using several separate hot dye baths. The exception is indigo, which must always be done in a separate bath. Silk is a protein fiber. The caterpillar spins a double-stranded protein fiber to make its cocoon. This fiber is made up of an insoluble protein called fibroin and a gum called sericin. Silk can be reeled or spun. When reeled, the fiber is called a filament and is wound off the cocoon in a single continuous thread. A strand of silk from a single cocoon can be up to 1 kilometer long. A single strand is too fine for weaving, so 6 to 20 strands are reeled together to make a thread. The sericin sticks the strands together to make a single thread about the width of a human hair. This thread can then be plied into various weights of yarn. Spun silk is made from strands that are too short or uneven to be used for reeled silk. Imperfect cocoons are also used for spun silk rather than reeled silk. Eri, a breed of wild silk found primarily in Assam, India, can only be spun as the fiber is not continuous. Tip: With silk fibers, there are no scales to open up, so silk can be mordanted and dyed at lower temperatures than wool. There are 4 main varieties of silk used for creating yarn and cloth. This is Bombyx mori. It is the silk that most people think of when they think of silk. Silk from the Bombyx mori accounts for 90% of the world's silk. The insect is completely domesticated and cannot survive in the wild. These are 3 types of wild silk: Tussah, Eri, and Muga. This is Tussah. The moth lives in forests of oak or jamun in India, Sri Lanka, Japan, and China. The leaves that the caterpillar eats give Tussah silk its natural gold color. Tussah has a shorter filament than Bombyx and can be reeled or spun. This is Muga. Muga is a famous wild silk that is only found in Assam, India. The caterpillar feeds on sam and swallow leaves. Muga is an ethereal, radiant, golden color like brass or gold. It is prized around the world. When dyed with natural dyes, the colors shimmer. This is airy. At Maiwa, we love airy silk because it is heavier and can often look like linen, yet airy still has the properties of silk. It is warm in the winter and cool in the summer. Airy is not shiny, but it still has a luster. The sericin of wild silks cannot be totally removed as it can with the domesticated Bombyx mori. Therefore, these wild silks tend to absorb less mordant and dye and can sometimes dye unevenly. A good natural dyer can anticipate this variegated color and use it creatively. These wild silks should not be overlooked by the natural dyer, as they are incredibly satisfying to work with. When thinking of cellulose fibers, cotton usually comes to mind. Cotton is almost pure cellulose. Cotton plants are part of the genus Gossypium that grow in tropical and subtropical areas around the world. The cotton fiber is a cellulose tube that grows inside the cotton boll. The center of the tube is filled with sap, but as the cotton matures, this liquid disappears and the tube collapses. Mature cotton fibers have a low moisture content. These are the most desirable fibers, both for textiles and for dyeing.
This is moisture meter.
Okay.
Here we see by this meter moisture of this cotton. Actually, normally the cotton should have moisture up to 8.5%. But now this vehicle is having a 12%, and these are maintained. There is a maintained 8%.
Cotton is graded by its maturity. Cheaper cottons may be made by blending mature and immature fibers. Cotton may be short staple or long staple, mill spun or hand spun. All are good for natural dyers. Cotton may be grown as conventional cotton or organic cotton. Conventional cotton is grown with the aid of fertilizers, herbicides, and insecticides. To aid in mechanical harvesting, conventional cotton is sprayed with defoliants prior to the harvest. Today, conventional cotton is often genetically modified. Organic cotton does not use chemicals in its various stages. Organic cotton is not genetically modified, and the farming practices are sustainable. At Maiwa, we are committed to supporting organic cotton. We have found that natural dyes yield deeper colors on organic cotton. This is Kala cotton. Cotton grows naturally in India. Up until the 1750s, two indigenous varieties predominated: Gossypium arboreum, known as the tree cotton, and Gossypium herbaceum, known as Levant cotton. Unlike conventional cotton, these varieties are native to India and are well adapted to the climate. These fibers show up in textiles from the Kutch region dating back thousands of years. More importantly, these local varieties are ecologically sustainable. Because they evolved in the extremely arid conditions of places like the Kutch Desert, they could exist without irrigation. However, they did not integrate well with industrial machinery, and so were neglected. Today, these old-world cottons are being revived and incorporated into handmade textiles. Because Kala cotton is grown to be hand-spun, it enjoys a tremendous advantage over conventional cotton. All cotton fibers contain pectins and waxes that need to be removed in the scouring stage. I'd like to take a minute and talk about naturally colored cotton. This is a fiber I became interested in for many reasons. In the 1980s, I was deeply inspired by a woman named Sally Fox. Sally graduated from the Pest Management program of the University of California and went on to study the naturally colored cottons. Sally Fox has dedicated her life to saving traditional varieties of colored cottons, and through traditional breeding, she has developed them into a longer staple so that they may be made into textiles for everyday use. These naturally colored cottons have been classically bred for color and length of fiber. They are not genetically engineered. Colors include various shades of brown, green, and even red and purple. The color does not fade and in most cases gets darker with time. Naturally colored cotton is believed to have originated in the Americas 5,000 years ago. According to archaeologist Dr. James Freeland, most of the colored cotton stock today comes from the pre-Columbian plants maintained by indigenous people on the northern coast of Peru. Tragically, by the 1990s, almost all indigenous cottons, both white and colored, were replaced by conventional cotton to aid in mechanical harvesting, spinning, and weaving. Like calla cotton from Kutch, naturally colored cotton grows without chemicals, needs little water, and has the remarkable quality that it comes by its unique colors quite naturally. I share this with you in the hope that you research more about Sally Fox, indigenous colored cotton, and the whole cotton industry. Linen, hemp, nettle, and jute. Bast fibers are bundles of relatively short fibers bound together with pectin to form longer, stronger strands. Bast fibers need to be processed to separate the fiber from the core and the skin of the plant stem. This process is called retting. Retting usually involves submerging the plant stem underwater until the non-bast portion of the plant begins to rot. This process not only removes the core and outside of the plant, it also removes some of the pectin, but not so much that the fiber becomes weak. It is useful to note that what remains after retting is a naturally rot-resistant fiber. Some pectin will remain in bast fibers even after scouring. This makes them a little more challenging to dye. This is linen. At Maiwa, we have a long-lasting, deep relationship with linen. We love it. We have made our reputation by naturally dyeing linen and using it in our clothing line. We have learned that we need to be patient, as linen needs longer mordanting times and longer dyeing times. But in our opinion, fabrics like linen were made to be naturally dyed. Linen comes from the flax plant, which is a surprisingly fragile-looking plant to contain such a strong fiber in its stem. Linen is one of the oldest textile fibers in the world. Flax is also grown for oil and seeds. Linen comes from flax grown in Europe, Russia, and China. In our opinion, Belgian flax is the finest. This is hemp. Hemp comes from the fast-growing cannabis sativa plant. Hemp was one of the first plants to be spun into thread. A fragment found by archaeologists in Mesopotamia dates back to 8000 BCE. Hemp and marijuana are both cannabis, but there are important differences. The fiber crop is often referred to as industrial hemp. The psychoactive chemical THC is much lower in industrial hemp. Industrial hemp also has much higher levels of cannabidiol oil, or CBD, which practically eliminates any psychoactive effects. The legality of industrial hemp varies from country to country. Hemp and linen fabrics have many similar characteristics. They both have extraordinary drape and sheen that increases with wear and washing. They are both strong fibers that have antibacterial properties, resist moth and insects, and biodegrade slowly. Hemp is famous for use on sailing ships for its high resistance to salt water. This is Himalayan nettle, woven into a lightweight shawl. There are many types of nettle, but only 3 can be used for fibers. All 3 may be dyed. Ramie is a nettle fiber with a long history. It grows primarily in India, China, and Southeast Asia. Ramie comes from the genus Urtica. Unlike linen and hemp, Ramie requires processing to remove all the pectin for it to function as a spinnable fiber. This process leaves the Ramie fibers with a silky luster, but less strength than linen or hemp. For this reason, Ramie is often blended with cotton, linen, or hemp. And finally, this is jute. Jute is another famous bast fiber which is used to make cloth known as hessian or burlap. Inexpensive burlap sacks, also known as gunny sacks, were widely used for shipping wool, tobacco, cotton, coffee, and foodstuffs. When used as sacking, jute creates a breathable, rot-resistant fabric perfectly suited to preserve both itself and its contents during sea voyages. Jute has been slow to find its way into the clothing world due to its coarse, scratchy texture. It is used in carpets, often as the warp for its strength, and then combined with a wool weft or pile. More recently, there have been small projects to refine the retting and spinning of jute, and then blend the fibers with silk, linen, or hemp for promising garment fabrics. It is challenging, but not impossible, to naturally dye. Agaves are most widely known as the source ferment for tequila and mezcal, but certain species also give a remarkable fiber. Agave is generally not used to make fabric. It is beautifully used as twines in woven products such as bags, shoes, mats, washcloths, and spa products. Here I want you to see the fiber and also some of the famous bags made by Mayan artisans living in Chiapas. The fiber is sometimes darkened through a process whereby the artisan treats the agave with a soot mixture collected from the domestic chimney. The result is a beautifully smoky-smelling brown. We have successfully dyed agave fabrics with tannins, iron, and cochineal. This should provide you with a good overview of the fiber world. Now you can apply your knowledge of fibers to understand how to approach almost any material for a dye project. Paper, for example, is made from pulped cellulose. Leather is a protein. Both paper and leather can be dyed naturally. Consider all the fibers in the world around you and just think what possibilities are waiting.